Question 8. Cooling tower has a capacity of 200 cooling tower tons. Tower operates in ambient conditions of 80 degrees Fahrenheit and 50% relative humidity. Discharge air is 28 degrees Fahrenheit and 60% relative humidity. What is the amount of water evaporated in gallons per hour? So, first step, we have to look up what is a cooling tower ton. So, 1 cooling tower ton equals to 15,000 BTU per hour. Now this measurement includes 12,000 BTU per hour. This is our evaporator cooling ton. And it includes 3,000 BTU per hour from heat picked up by your compressor. So essentially, if you take a look real quick at your refrigeration cycle, this is your evaporator. Then it goes to your compressor, your cooling tower, and thermal expansion valve. So what happens, you pick up 12,000 BTU per hour into your evap from the space. You pick up 3,000 BTU per hour from your compressor, and you relieve that heat to the atmosphere of 15,000 BTU per hour. Now let's focus on two conditions that we have to get our enthalpies and our moisture content. So first condition, we have 80 degrees dry bulb, air entering, and 50% relative humidity. We go on our psychrometric chart, we find 80 degrees, we go to 50% relative humidity. Our moisture content, you can read it here, will be about 0.0109 pounds of moisture per pound of dry air. Our enthalpy, if you interpret it here, is going to be roughly 31.2 BTU per pound of dry air. Our second condition, leaving cooling tower, is 98 degrees Fahrenheit dry bulb and 60% relative humidity. Now let's go and interpret it as well. So 98 roughly here, 60 relative about here. We go interpret our enthalpy. So this is enthalpy 1, 2, moisture 1, moisture 2. So our moisture for the second condition is going to be roughly 0.0236 pounds of moisture per pound of dry air. And this is going to be 49 for enthalpy, 0.6 BTU per pound of dry air. Now we can calculate conditions on our cooling tower. So in order To find total heat, you have to type in heat gain calculation, and this gives us a formula of Q total equals to 60 multiplied by 0.075 multiplied by QS, which is CFM, multiplied by delta H, which is change in enthalpy. So our total heat is 200 tons for our cooling tower. We know that each ton has 15,000 BTU per hour. So plug and play. 60 multiplied by 0.075 gives us 4.5. Multiplied by CFM. Multiplied by our change in enthalpy, which is 49.6 minus 31.2 BTU per pound of dry air. I don't really concern myself with units here, since the 4.5 includes a conversion factor. So basically, if you follow this formula, you're just going to get CFM, which in this case is going to be 36,232 CFM. Now, CFM, for those who that do not know, is basically cubic feet per minute, which is volume flow. Now, our difference in moisture content that we obtained earlier is equal to 0.0236 minus 0.0109, and the difference is going to be 0.0127 pounds of moisture per pound of dry air. Now finally, we can get our evaporation rate. So we put our volume flow 36,232 cubic foot per minute. You put our moisture difference, which is 0.0127 pounds of moisture per pound of dry air. Now we put conversion. We have 60 minutes in 1 hour, so minutes will cancel out. We have to obtain our density. So if you go back on this chart, we obtain density for our initial condition, which was here. So if you check, the density should be roughly 13.7, just roughly, for that condition. So once you get that, you can divide. You can take a reciprocal of 1 over 13.7. That's going to give you this value, 0.073 pounds of dry air over cubic foot. That's going to cancel our cubic feet and our pounds of dry air. Finally, we know that 1 gallon has 8.34 pounds of moisture. That's going to cancel out our pounds of moisture, and our final answer is 242 gallons per hour.